Hey guys, what's up? Welcome back to another episode of It's About Everything. So in today's episode I'm going to show you how you can measure more than 10 amps such as 20 amp, 50 amp or 100 amp continuously with these cheap multimeters. These multimeters can measure up to 10 amps unfused for 10 seconds as it's written on this meter, and that's the maximum capacity of this meter. Now how I'm going to measure 100 amps with this meter? First of all, I'm going to run a small load in series with my multimeter in 10 amp setting. I'm using my DC fan here which pulls 1 amp from the battery. The way this multimeter measures current is by passing the current through a shunt resistor of a certain value and then measuring the voltage drop across the resistance, which is in millivolts, and then it calculates the value according to Ohm's law, which is current equals voltage drop across the known resistance divided by the value of the resistance. Now one thing all multimeters have in common is that they can measure millivolts down to 1 millivolt accuracy and up till 2000 millivolts. So all we need is that we need to make a shunt resistor to measure the current. You might be thinking what value of shunt resistor to choose. That might be a little bit difficult to decide because you don't want a voltage drop of more than 75 to 100 millivolts across the resistor, or it will hit the shunt resistor and the reading accuracy will drift away. If you have searched for shunt resistor online, you will find a lot of them with different amp ratings, but you will see one thing in common, which is they all have written on them 75 millivolts or MV and the current carrying capacity such as 100 amps, and you can easily calculate the resistance value from this voltage drop reading with the help of Ohm's law. For example, if a shunt resistor is rated for 100 amps and 75 millivolts, then according to Ohm's law, which is resistance equals voltage drop across the resistor divided by the current flowing through the resistor, or 0.075 volts divided by 100 amps equals 0.00075 ohms. So it's clear that we can't measure in milliohms or microohms with our multimeters. So how will we make the shunt? Well, there is a way of making a shunt without the need of a milliohm meter, and I have used the same technique and made a shunt myself, which I have tested with 25 amps and it works. So this is the shunt that I have made. Okay, so I have used a bicycle spoke here to make the shunt. You can see some wires attached with the shunt, two wires close to each other and another one on the other end. That's because it's double shunt made in one. So you can see here all the wires attached, and making this shunt is really simple. All you need is a constant current power source or a load such as the DC fan that I used. It pulls 1 amp constant load at 12 volt. So I connected this fan in series with this bicycle spoke, and I used my multimeter in millivolt setting, and then I actually slide my probe across this spoke and find out the position from where it shows a drop of 1 millivolt and 10 millivolt. So the longer distance is a voltage drop of 10 millivolt and the shorter distance is 1 millivolt. So as the voltage drop is directly proportional to the amount of current flowing through this shunt resistor, and as I already know that 1 amp will be pulled through this shunt by the DC fan, I used my multimeter in 200 millivolt setting and slide the probes across the spoke and marked the two places, the shortest distance at 1 millivolt and the longest distance which is at 10 millivolt. Okay, so here I have connected the shunt in series with the fan. So you can see it's connected on the negative side of the battery, and I have in my hand the terminal of the fan, the wire of the fan. So right now I have connected my multimeter with the longest distance, the 10 millivolt drop section of the shunt at 1 amp, and you can see the multimeter is set to 200 millivolt setting. Now as I connect it with the wire, the current starts flowing through the shunt, and you can see the voltage drop is 10.2. so if I move the decimal point one digit to the left, it becomes 1.02 amps. So you can see it's showing 10.02, so I have to divide it by 10, which becomes 1.02, or shift the decimal point to the left, one digit to the left, and you don't need to divide it again and again. Now I'm going to connect it to the 1 millivolt drop point at 1 amp. So that is the shortest distance in the shunt, and with 1 amp load the voltage drop is only 1 millivolt, so I don't have to divide it with any digit. I can straightly take the reading from the multimeter. 1 millivolt means 1 amp, and I have measured it up to 25 to 30 amps. I actually connected it with the UPS, computer UPS, and I attached load with the UPS, and I measured how much current it pulls. So I actually used the multimeter amp setting, 10 amp setting, to calibrate this shunt, and then I was able to measure much more higher current. So you can see the multimeter is drifting a little bit, because at millivolt, when the probes touch with each other, it generates a little bit of voltage, and that's what it was showing. But once I separated both the probes with each other, you can see the reading is 0. So you need to use alligator clips here, or much more stronger joint such as soldering or anything else, or clips. Here I just twisted the wire on the top end of the multimeter probe, and the probes were touching the ground. So if there is not a perfect connection, then the multimeter will start showing readings without any load, because it's just a voltmeter, and it measures voltage. If you touch both the probe with your hand, it will start showing a voltage, a potential difference. But once it's connected with the shunt, it becomes 0. So now you can see it shows 1.0, which is actually 1.01 amps load, but here the resolution is much more smaller, so 1 amp load. So the distance that the current is flowing and the voltage is dropping is approximately 1 inch. So 1 millivolt drop in 1 inch distance, and this bicycle spoke is made out of some kind of spring steel. So copper is the best option to make a shunt, and copper also has some voltage drop when a huge amount of current flows through it. So if you calibrate with a thick copper wire, which can take up to 100 amps, and if you set it to 1 millivolt drop at 1 amp, then you can easily measure up to 75 amps or 100 amps, and there will be a 100 millivolt drop. So this is the connections, as you can see. So this is how you measure higher current using a normal cheap multimeter by making a shunt. So this was it, guys. Thanks a lot for watching. I hope you understood what I have shown in this video? If so, then you can please comment down below what do you think, and if I said anything wrong, then you can say that to me, tell it to me on the comment section below. So thanks a lot for watching. Subscribe to my channel, share it with your friends, and hit the like button. I'll see you soon. Have a nice day.